Welcome to Los Angeles Data Platform User Group. Good time of the day, everyone, wherever you are. By the way, please drop your city and country into the chat so we know which communities we are serving. Again, welcome to Los Angeles Data Platform User Group. Thank you for joining us today. My name is Steve, and I'll be your host and moderator of this virtual meeting. I'll be joined by probably just Yelena. Yelena is going to be doing raffle, and Yelena is part of our nonprofit, also part of our SQL Server Los Angeles organization team. Looks like I'm not going to be doing social media. I'll skip that. Again, we have recording anyway. If you're attending for the first time, here's plenty of links that allow you to find us on different platforms. Be it Facebook, Twitter, or anything else. We also have a YouTube channel and Rumble channel as well. And from time to time, then speakers would like to share materials and they don't have a GitHub. We have our own GitHub. This way we can share the session materials as well. Please feel free to join our mailing list. So you can do is just either click on the URL or scan the QR code, and that would add you to our mailing list. And this session is sponsored by Data Driven Technologies, and Data Driven Technologies, or in short, DDT, is the organization behind Los Angeles Data Platform User Group, this group. This group's monthly meetings, as well as our mega once-a-year event called SQL Server Los Angeles, or as we call it now, Data SQL Server in LA, which was 4 or 5 days ago, which was in person. And we are offering every meeting a T-shirt, so you can scan the QR code or click on the URL, and you'll participate in raffling a T-shirt. Now, the T-shirt on this image is not exactly what we are offering now. We can only do one color. And one thing that I need to mention, of course, that we can only afford to ship it to US. And let's move on to the next slide. And during the presentation, please feel free to drop questions in chat. Into chat, or alternatively just unmute yourself or ask questions. But again, probably better just chat. And without further ado, let's move to the rockstar of today's online meeting. Tim, please take it away and introduce yourself.
All right, thanks, Steve. Appreciate everybody joining in whatever time zone you're in. If you're like me, if you're Central or East Coast or further that way, it's a little later in the day. So wherever you are, thanks for joining up. I'm going to share my window here. All right, Steve, if you can let me know if you guys can see my PowerPoint, okay? All right, yes. So
perfect.
All right, yeah, perfect. Thank you. So in this session, we're going to talk about change tracking and temporal tables. So I've done, just to give you a little history, I've done a presentation separately on SQL Server change tracking, and then another one separately on temporal tables. I've done those several times in the past. And invariably, every time I would do a presentation on one or the other, I would get a question about the other of these two technologies. So because they play in a similar realm, not exactly the same, but a similar world, I decided to go ahead and talk about them both in the same presentation, demonstrate a few things that they share in common, and then some differences as well, and some use cases where one would have an advantage over the other. So the things that we'll talk about, I'll talk at a high level about change detection in general. So the need for it, what it is, cases that you would use it. We'll talk about in a broad stroke some change detection methods and how you would go about doing change detection. And then we'll get specifically into the details of change tracking followed by temporal tables. So a little bit about me. Again, my name is Tim Mitchell. I'm based in the Dallas area. I'm a data architect, and I own a company called Tyleris Data Solutions. We specialize in data warehousing, data architecture. We do a lot of ETL and data engineering. If you want to follow along with some of the stuff I do, I blog a little less frequently these days, but I blog at timmitchell.net. If you want to follow me on Twitter, I'm at Tim_Mitchell. And then our website, our company website is Tyleris.com. So let's start with kind of a broad umbrella of change detection in general and what that is. So change detection is effectively the filtering of data to detect data that's either new or changed or has been deleted since the last time we analyzed the data. So to give you a little background of the type of work that I typically do, I work a lot in data warehousing. So I deal a lot in batch data processing, where if I've got a data warehouse or an ODS or even a data lake that we're pumping data into, we'll typically do that as a batch operation. And key to making that work is identifying what data we need to move over. I'd rather not move everything over from all my sources into wherever we're distilling the data into. So I'd like to have some method to detect what's changed and what's new, as opposed to trying to pull everything over. That's where change detection comes in, is figuring out the delta of that data so we touch as little data as possible. So some of the reasons for that, certainly performance at the top of the list. If you touch less data, it's going to take less time to process. So if you're building any sort of a data movement pipeline, whether it's real-time streaming or whether it's an ETL and a batch operation, if you can touch less data, it's going to cost you less time. In a lot of cases, it's going to cost you less money as well. But also the historical record. So there are some things that over time that will change that you might want to persist that history of changes and see not just what the data looks like right now, but what it looked like at some point in the past. So those are two big reasons that you want to pay attention to these change detection patterns that I'm talking about. So broadly, a couple of different ways we can do this. Ideally, if you can do your change detection and change management at the source, that's going to cost you less time and less resources. That means that you're introducing a lesser amount of data into whatever pipeline you built, again, whether it's real-time streaming or batch processing. But that does depend on having some sort of reliable system that will accurately show this is new data, this is changed data, and if you're managing deletes as well, this is your deleted data. You can do it at the destination as well. And when I say destination, I mean within the data movement pipeline or upon its arrival at the destination. If you're filtering this way, it does have the fewest amount of assumptions, but if you've got a large volume of data, let's say you've got 1 billion rows in your source systems that you're pulling over. If you're doing all that within your ETL or your data movement pipeline, or once it arrives in the destination, you're touching far more data than has actually been changed. So while this is an accurate way to do it, it also, in some cases, will cost you more time and money. So some of the tools that we have at our fingertips for change detection, a lot of tools within the SQL Server. The two that we'll talk about, obviously, are change tracking and temporal tables. Many of you have probably used the merge statement as well. It's not necessarily a source change detection mechanism, but it will let you effectively identify what's new, what's changed, and what's been deleted when you're loading data from A to B. If you're using a tool such as integration services, such as Azure Data Factory, and many other third-party tools that do data movement, they'll have their own built-in tools. And then even third-party plugins. Things like Redgate, for example, have some plugins. SentryOne has got some plugins that you can plug into other tools and do change detection and change management as well. So some of the methods that we'll see for that, the good old-fashioned timestamp. So you've all seen this. If you manage any sort of data at all, you've seen at the row level, this is the date and time that a record was inserted. This is the date and time that it was updated. And in theory, that works well. This is dependent on, though, having a reliable system that if a record is inserted, if a record is updated, that field is all the time, is every time updated to reflect when it was either inserted or updated. So I've seen cases where this works reasonably well. I've seen cases where on the application management side, they didn't do a good job under the hood of designing it to where it does manage that updated value. So you might have a record that was updated, was inserted, but it's not coming up within the time frame that it's supposed to. So that's not to say that all timestamps are bad, a date and time timestamp at the row level, but if it's something that's not systemically enforced, do be aware that there can be some concerns there about having accuracy within that change detection mechanism. Next up is the option to do row hashing. So this is not one of my favorite methods, but it is an accurate method if you can't filter data at the source. So the way that works is you create a hash on the data that you're pulling into your pipeline, and then when you store the data, you create a hash as well. So you take several different values, you combine them together to make a binary value. And then you can use, instead of going column by column and row by row and detecting this is a new row, this is a changed row and whatnot, you can use that hash to determine, based on that hash and the combination of the primary key column or columns, whether that's a new row, a changed row, or in some cases, if it's a deleted row. This is bordering on brute force because you are dealing with data at the column by column level, but you're pre-calculating that hash to make it a little faster when it does that comparison. And then the last one, and this has no assumptions whatsoever, is doing brute force. So I'm pulling in a billion rows of data from my source system. I'm loading it in my ODS, my data warehouse, my reporting database, or wherever it's going. And I go row by row and column by column to detect, is this new, is this changed, and then deal with that accordingly. This works almost 100% of the time. It is the least efficient method of all the ones that I've described or will describe later on tonight. You can do this just about everywhere, but do be aware that there are performance implications for that. If you're dealing with any sort of hosted environment where you're paying for data ingress, data egress, this will have the highest costs as well. So do be aware of that. And then most ETL tools will also have their own, their baked-in ability to do that change detection as well. If you're using integration services, ADF, MuleSoft, the various ETL tools that you can buy, DataStage and Informatica, they're going to let you do some change detection and change management inside those tools as well. In many cases, they can leverage the tools that are already in the database engine that you're using. So if you can use those tools, certainly coupled with the ETL tools, whatever is baked into that ETL tool, you can find the most efficient solution based on the combination of those. And then another one in SQL Server is change data capture. So I want to make sure that we're square on terms here because I deal a lot with change tracking. So we'll talk about change tracking in depth. We'll talk about temporal tables in depth. Anytime I talk to a client about change tracking, it seems like they mix that up, at least terminology-wise, with change data capture. Do be aware those are two completely different things. They play in the same sandbox, so to speak. They do some of the same functions, but they're very different tools. So change data capture has been in SQL Server since I believe 2008, maybe 2012. It's been around for several versions, and it's in all the currently supported versions. This is source-side detection, but it has the advantage of having your full change history for whatever window you specify. So it's not just identifying this row has changed and it was deleted or it was updated or it was inserted since the last time we checked and ran the ETL. This will have that full change history. It is based on the transaction log, and it's an asynchronous process. So there can be some latency in using change data capture. CDC is one of those tools that I really thought I would use more of, but I can count on fingers with fingers left over the number of times I've actually used CDC in a production scenario. Most of the time, and this is perhaps just a glimpse into the type of work that I do. In dealing with data warehouse work, I don't typically have to store the full change history. Typically, I want to know just these rows have changed, these were inserted net new, or these were deleted since the last time we ran our ETL or our streaming load cycles. So you may find something different in your environment. I very rarely have a need to use change data capture, but it is really effective, again, if you need to have that full change history for a period of time. Be aware that if you're using change data capture or you're considering it, if you're running an older version of SQL Server, specifically anything earlier than SQL Server 2016 SP1, that does require Enterprise Edition. If you're on 2016 and you've upgraded to at least SP1, that can be on any edition of SQL Server and doesn't require Enterprise Edition. And this certainly is, just to set the stage, it is more complex than either of the two things I'm going to talk about in more depth a little later today. All right, next up, change tracking. We will get into the weeds on this. Change tracking is by far my favorite change detection mechanism. If I have my choice to pick whatever I want, if it's purely for change detection, change tracking is my go-to tool. It's very lightweight. It's in every edition of SQL Server. It doesn't require anything special of the database engine. And it doesn't have a lot of requirements on the tables that we're tracking. It does require a primary key for any table that we're using to track any changes. It does require that it have a primary key. As good data stewards, most of us have primary keys on most of our tables anyway, so it shouldn't be a concern for most of your tables. And it'll track any change. It'll identify any row that has a change, whether it's an insert or an update or a delete. It's important to remember on this that unlike change data capture or unlike temporal tables that we'll talk about in just a bit, change tracking doesn't keep the history of that data. So if I insert a customer record yesterday, I updated it late yesterday, I update it again today, and then I delete it later today. If I go back and look at that history, change tracking isn't going to tell me that this customer looked like this, then they look like this, then they look like this, and then they were deleted. It's going to tell me for any given point in time, the net change was this primary key was inserted, or this primary key, the net change was it was inserted and then later on updated. But it doesn't store the full history of those updates, only the fact that that record has been inserted, updated, or deleted within whatever time I specify. Like I mentioned, it does come with every version of SQL Server, including Express. So I know most of us probably aren't running SQL Server Express, but this is in the free version of SQL Server as well. And the way you manage this is you turn it on at the database level, but you still have to enable it on a table-by-table basis. So just by virtue of turning it on at the database level, it doesn't really do anything. You have to go table by table and specify which table or tables you want to include in that tracking. And then an option that I usually don't turn this on. Again, this is reflective of the type of work that I do. You can tell change tracking in that configuration at the table level that you want to track not just the fact that a row was inserted, updated, or deleted. You want to track the individual columns to say, I want to know which columns were updated if it was an update operation. Again, I very rarely do that. Most of the time, the work that I do, if the row has changed, I'm going to handle it the same way, whether one column has changed or 50 columns have changed on that row. You may find something different in your environment, but do be aware that there is functionality in change tracking to identify not just the row, but to identify column by column, whether that column was updated in an update operation. I mentioned earlier, it does require a primary key on any table that you're tracking. Other than that, everything that makes change tracking run is going to be transparent to anyone using that table. All your CRUD operations, your create, read, update, and delete, those work exactly the same on a change tracking table as they would on just any regular old table that you create manually. The only difference here is you're going to have the ability to look back and see for a given period of time, was this row inserted, updated, or deleted within your database? So the way this works under the hood is for any set of changes that occur, it's going to detect the version number that change belongs to. So that doesn't mean that you're going to get a different version number for every single row. What that means is for every batch operation, you're going to get a new version number. So how that's going to work is if you write an update statement, update this table, set this value to X, that's going to increment and give you a new version number. If you write another update statement and say delete everything from this table, that's all going to be in one version number, even though it might be a million records. So just keep in mind that your version number will increment not at the row level, but at the operation level. So I'll show you some examples of that once we get into the demos in just a second. So some of the common functions that you'll see, there's three that you're going to use, really two that you're going to use all the time. You might use a third if you're doing a lot of column level change detection. Change tracking current version is the first one that we see there. This one is the one to identify at the database level, what's our current version ID. So this helps us to identify the starting and ending point for every load operation, for every data movement operation that we're going to engage in. The second function that I have listed there is change table. That's actually a set-based or a table-valued function that lets us pull back the list of primary keys along with the operation that took place, either an insert or an update or a delete for every row that we have in that table. And then finally, change tracking is column and mask. I know that's kind of a long one, but that's the function that if you've enabled column level change detection, this is the one that you would use to identify was a given column updated, not just a row, but was a specific column updated when that row was updated. So using change tracking, a common design pattern, and this is one that I use in fact, I can't think of a single instance where I didn't use this particular design pattern. I store the version number from when I run that ETL process or that data movement process. I'll store that in a table. That becomes the ending point for this load. And then next time we run that data movement operation, that's the beginning point of the next load. So think of it as like a bookmark in a book. So where I end off right now is where I start the next time, and so on. You can store that in code. You can put it in a config table. I'm a data guy and I deal in tables, so I'd rather just store that in a separate table and have that part of my ETL operation or my data movement operation to bring in that value that was the marker for the last time we ran that ETL. All right, so that's a quick overview of change tracking. Let me pause there and ask any questions about that part of change tracking. I'm going to get into some demos and show you some implementations, but for right now, any questions that have come up so far?
No questions from the chat, but maybe I can ask you a question. So if the CDC is using log, what kind of mechanism change tracking is using?
Good question. So if CDC is using transaction log, what is change tracking using? So it's using, I like to call it a kind of a shadow table. So under the hood, it's using a table that basically persists the primary key for any rows that have changed. It'll have the version number, and then it'll have the type of operation that took place. And then it's going to have a binary column that will store, if you turn this on, that will store the list of columns that were affected by that change. That's not going to be physically instantiated as a table, but it's something that's managed entirely within SQL Server, within the database engine. It's not something that you'll query directly, but if I can go back to my slide deck for just a second, the way you'd access that is by using that change table, table-based function, table-valued function, to be able to access that data.
Got it. So you're saying that there are hidden tables you can access only through functions?
Correct. That's exactly right.
Okay, yep. Thank you.
All right. So if no other questions, I'm going to show you briefly how to do this in the UI, but I'm going to spend most of my time in code because if you're a data person, you don't want to go clickety-click through all these operations. You want to find a way to automate things. But I will show you just briefly how you do this if you're going to turn this on through the UI. So I've already got a database called change tracking out here. So I'm going to go ahead and right click and go to properties on the database. And then right in the middle of my tabs on the left is the option for change tracking. So you can see I've already got this turned on. If I can move this out of the way for just a second, I'm going to open up one more database and show you what that looks like if it's not turned on. So for this database, you can see it's not turned on. It's set for change tracking is set to false. When I turn that on, I've got a couple of different options here. So set that to true. It's going to light up these other options that I have. The retention period, I've set this to 14 days. So what this is saying is, and Steve, to your question earlier, this is the retention period in which will hold all that shadow information that change tracking will use to track those changes. The default is actually 2 days. So if you don't set it to anything else, you just turn on change tracking, you're going to get 2 days worth of history. Is that good or is that bad? It's neither one really by itself. But I like to widen that out to something bigger than 2 days by default, if for no other reason for this right here. If you're running an ETL process, a batch ETL process, and that's running every single day. Now let's think worst case scenario, if there's a long weekend and that process starts to fail. If it fails over a long weekend and maybe you have a failure where you don't get notified when that process failed, if you come back, you're going to come back after 3 days have expired, which means that all of your change tracking history is going to be gone. It doesn't mean you've lost data necessarily, but it means that now to run that data movement, that ETL process or that streaming process, you now have to go back and reconcile manually what's changed versus what's been inserted, what's been deleted, and so on. So my preference is to set that to something big enough that a long weekend or a vacation or something like that would never exceed that time period, just in case something starts failing and for whatever reason someone didn't get notified and didn't get that reconciled in a proper amount of time. But do be aware that that's where this option is. As I mentioned earlier, you enable it at the database level, which is where you set your retention period. And then at the table level, we'll turn it on table by table for each of the tables that we want to track.
So I can safely assume that if you put a big number, your database, because of those hidden tables, is going to grow.
Correct. So that's the risk that you have of storing too much data, is that for every operation, that every change that takes place on any row in that table, it's storing a copy of it in that table, that hidden table that you can't see. So the table, that data is persisted, even though you can't query it directly. So if you set this to 365 days of data, the plus side is you could go back 365 days and see primary key value by primary key value, which rows were changed, which ones were inserted, updated, and deleted. The downside is you've got this big list. If you've got a particularly busy or active table, you've got a lot of activity that you're storing that you probably won't need access to.
Do you have functions that allow you to clear out those hidden tables? Maybe also a function that allows you to see what exactly the size of this hidden table?
That's a great question. So can you clear those out? So the short answer is no, but you could turn off change tracking and turn it back on, and that will implicitly clear that out. Can you see how much storage that's using? I haven't found a way to do that. But here's in all my use of change tracking, and I'm fairly conservative in what I do apply change tracking to. I don't just, if I'm going to turn it on for a database, I turn it on for the tables that we're going to need, as opposed to just turning it on for every table. But I've never run into a situation where either space or performance has been an issue and change tracking appear to be the culprit. It's never painted me in a corner like that before. So that's not to say that it couldn't happen, but I've never been faced with either a performance or storage issue that was even hinting at being caused by change tracking.
Got it. Okay, thank you.
Yeah. All right, so again, these are options that you can set when you're turning it on at the database level. These are all scriptable, just like almost everything else is when we're dealing with SQL Server. And then at the table level, let me go back to my change tracking database real quick. At the table level, once you've got change tracking enabled at the database level, then you can go into your table properties, and then it's got its own change tracking tab. You can turn on change tracking individually at the table. And this is where you set, if you've got it turned on, you can set it to track the columns that were updated. So again, this is not really something that I do a lot of, but if you wanted to know column by column which ones had changed, you can turn that on at the table level as well. All right, so I'll walk you through. So that's about all the time that we'll spend in the UI. I'll spend most of the other time in the code actually showing you how this works. So let me run this prep operation. I'm going to add a primary key to the table that we're going to deal with. get a little more screen real estate so we can walk through here. All right, I mentioned earlier when we were talking about design patterns that my preference is to have a table in either the database that we're tracking or in a different database entirely that manages that point at which we ended the last load, which is the point that will kick off the next load. I've created a table in here, and you're going to see me use this in every script that we have in here. The table that I created is in the ETL schema. It's called Change Tracking ETL version. You can name yours whatever you want. You can put it in a different schema in that database. You can create a whole separate database just for that table if you want to. But ultimately, you'll want to have some storage mechanism to track that value. Mine is really simple. The only thing I'm storing in this one is the name of the table that we're tracking, and then the change tracking version number. Do be sure that when you store that, you're storing it as a big int value. So that's actually a big int in that table value function. And then in the change tracking current version function, it's going to return a big int. If you use an int, it'll be fine for a while. Once you hit that threshold of 2 billion and some change, which on a busy database, you're going to hit that at some point. You're going to exceed that number. So make sure you use a big int there. One thing I'll point out real quick, and let me go back to the database just for a second. That version number that we'll talk about throughout this presentation, the version number will increment at the database level, not just at the table level. So if you have 5 different tables in a single database that you have enabled with change tracking, if you make a change to table 1, it's going to increment your version number from 1 to 2. Separately, if you make a change to table 5, it's going to increment that from 2 to 3, and so on. So that's part of the reason why it uses a big int, because that's tracking, it's incrementing not just the changes at a single table level, but across the entire database. Not the entire instance, but just that one database. All right, so we'll create that table, and then if it's already there, we'll go ahead and truncate that.
Why is it nullable?
Say it again.
Why is the version number, the change tracking version number, a nullable column?
Yeah, that's a good question. So when we first create this table, we don't have a value in there at all. So what I'll do when I populate this is I'll put the table name in there, and we'll not have a value in change tracking current version. The first time we run an update operation on that, it's going to replace that value that's in there. So it'll replace a null with something that's not null. Once we've got that set, so I'm going to change database to master. We're going to enable.
Are you sharing the screen?
Yeah, are you not seeing it?
No. Maybe just me.
I'm seeing it.
Okay.
Continue, then it's just me.
Steve, it sounds like you had some Teams issues for a little bit tonight. So yeah, if somebody else isn't seeing it, let me know. But since at least one of somebody else is, then hopefully everybody is able to see that okay. All right, first thing that we'll do is that first operation that I showed you in enabling change tracking at the database level, this is the code equivalent. So if that database is not listed in the databases for change tracking, then alter database, and I should have named the database something different because we're using the same word, but alter the database named change tracking. I'm going to set change tracking on and then set my retention period to 14 days. Now I'm going to change context, jump over to that database. Now that we've enabled it at the database level, now I can go into any of those tables that I wish to enable change tracking on, and table by table, turn that on. So I'll check to see, is the table employees already listed in the list of track tables in this instance? If it's not, I'm going to alter that table, enable change tracking, and I'm going to leave track columns updated equal to off, because I don't care if individually if a single column is changed. I want to know if that row is changed. All right, and then finally, we'll delete from change tracking where the table name is dbo.employees, and then finally insert into that change tracking table that we created up above the top of the script, dbo.employees and change tracking current version. Now, I believe to the gentleman's question earlier about leaving that column nullable, I believe if we haven't made any changes, we're going to get a null value here. So let me just run that to confirm that's the case. Nope, I need to turn that off. That's still not resetting. How about we turn this off for the database? Oh, that's right. You have to turn it off individually for the table. So I was just going to check to see if we turn that on for the first time. I believe, if my recollection is correct, the first time we run this function, change tracking current version, it's going to return a null because we haven't actually had any change since we turned on change tracking. So that's what we're doing here is the first time we use that table, we're going to insert the name of the table that we're tracking, and then whatever that current version is. So right now it was 12 and some change, 1294, 1247, pardon me. Now I can keep on running this. It's going to give me, as long as there aren't any changes taking place, I'm going to continue to get that same value. So we've got that turned on. So now let's go in, and for that table that we're tracking, let's make a few changes. So it was the dbo.employees table that we had made changes to, and that we had turned on change tracking for. So we're going to run a few CRUD operations here. So we're going to update 39,000 rows, set employee type equals T. We're going to add a handful of new employees, and then we're going to delete about 9 of those employees. All right, so because we had turned on change tracking on that table, now I can go back and use those change tracking functions to see what it was that has changed in that data. So in this script, I'm going to create a big int value called CTVER, which is the change tracking version. I'm going to select into that variable the change tracking version from that ETL.changeTrackingVersion version table that I had created, where the name equals employees. And if I just throw in a select CT, I'm just going to select the value out of there just to show that. Still 1247. Actually, that should have incremented. No, I must have queried that after it incremented. So now that we've got the version number, we're going to see what changes have taken place since the last time we stored that version number. The way that we're going to do that is we're going to touch the employees table, and we're going to get all the data for the employees table. But the main place that data is coming from is that change table function. So this is a table valued function, and it's expecting 3 parameters passed into it. First parameter that it expects is the word changes. Now, there are some other options that you can pass in here. You can tell it, I want to get the changes for a specific version. I don't think I've ever used that. You can say for version 1246, what were the changes for this table that were in that specific version? It might be handy for edge cases. I've never, ever had to use that. Second parameter is the name of the table. Keep in mind, you're actually putting in the literal name of the table. You're not putting that in quotes here. If you put it in quotes, it will give you an error. So it's just going to be the literal name of the table. And then followed by comma. These aren't all comma separated. So changes followed by the table name, then followed by comma. And then we're going to pass in the version number. What we're saying is we want to get all the changes that occurred after that version number. So after 12.4, whatever that number was, 1247. We had stored 1247 in the table. So 1248, 1249, 1250 should be those 3 changes that we made. And if we run that entire query, now we're going to see CT version that we stored in the configuration table was 1247. And then we had those 3 sets of changes that we made back on the previous script. We did an insert, we did an update, we did delete, all within that change set. And what we're going to see there, let me comment this out just to get some more real estate. So what we're going to see there is all the data on that left join. So we're using change table and then left joining back to the original table that we're tracking on employee ID equals employee ID. I'll come back to that in just a second. We're going to order by the operation. And you can see we've got a bunch of nulls right up here, followed by some actual data from there. And if you look at the column labeled sys change operation, this is the column that I sorted by. I grouped those purposefully so we could see those different operations. If you'll remember, the update operation that we did was about 39,000 rows. So scrolling through there, there's a whole lot of those. In fact, I think everything all the way to the bottom of the list is just updates. If I go back to the top, I've got two other operation types. The first 9 rows there are the ones that we deleted. And then the 3 following that are the ones that we inserted. So I for insert, D for delete, U for update. So if your load process needs to know more about the row than just it's changed since the last time we ran the ETL, this will let you bifurcate that data and say, I want to handle my inserts differently than my updates, differently than my deletes. And you can branch those out accordingly based on the type. The reason we're seeing nulls in most of these columns up here, the first several columns up here, is when we do the change table function, that's bringing back all the primary keys for that table, irrespective of whether or not that primary key is still in the table. So when we set up change tracking, what happens here, I said we were going to come back to this join. What happens here is that table that's the hidden table that's managed entirely by SQL Server, it will create for this particular table, it's going to create another set of, basically another set of primary keys under the hood. So if I call my primary key employee ID on the table that we're tracking, it's going to call that the same column name when I use that change table function. So effectively, I'm going to join my primary key back to my primary key. Again, I have to do a left join and not an inner join because I'm going to have some values in my change table function, specifically the deletes, where that row is no longer in the table that we're tracking. So that's why we get this set of rows up here. We'll get these 3 that were the ones that we had inserted, and then the rest of those were all delete operations. And you can see individually, I mentioned earlier that all those changes, the version numbers aren't at the row level, it's at the batch level. So here's my 1248 all the way toward the bottom. 1249 was the next one, followed by 1250. So those are the 3, even though we touched 39,000 some odd rows of data, we only incremented our version number 3 times because we undertook 3 different batches of data, 1 insert, 1 update, and then 1 delete. So that's how you'll access that. You'll definitely need to get to know that change table function. The syntax is a little bit quirky, but once you've done it a couple of times, you'll figure it out pretty quickly. As I said, the first parameter that you're going to pass in, it's simply the word changes. I've never had to do anything other than get the changes for a given table, and then everything beyond a certain version number. Now, one design pattern that I'll typically use is rather than just saying, give me everything that occurred after CT version, is I'll go ahead and run that change tracking current version function again. And I'll get, once I commence with a data movement operation, once I commence the ETL, I'll say, I know what my beginning point needs to be because the beginning point for this load was the ending point for the last load. I also want to have a fixed ending point for this load because I don't want to say, give me everything that happened after that, because there might still be updates taking place right now. And I don't want to get a partial load where my ETL process starts expecting to end here, but it actually has further changes after that. So I'll go ahead and run change tracking current version one more time and either write that to a table or use it if I'm just doing like a 1 script operation, for example. I'll use a SQL Server variable, a T-SQL variable, store that value, and then I can apply, and I'm just going to pseudocode this out, where ct.version is less than my variable. So I've got for this one, I've got my beginning point where I'm starting off. I've got my ending point, a firm place where I'm going to finish that load. And then at the end of this operation, and we'll look at this once I get into the next demo, this ending point for this operation is going to move into what was that current change tracking version. And this one ultimately will be stored in the table that's our starting point for the next load. All right, so that's just a really quick drive through on how to access those functions. Let me show you, if we're going to pseudocode this out, what this would look like as far as actually running ETL. Zoom in just a little bit in case that's too small. So here we're starting off. I'm declaring a couple of variables, CT version to start with, CT version end, just like I described here, and then the table name that we're working with. I'll first start off and grab the current version. So this should be 1250 as of right now. Once I run change tracking current version, this should get that'll get 1250 right now because we haven't made any changes subsequent to what we did just a little bit earlier. So that'll be the ending point for this load. So once we do that, we've got a pseudocode for if we were running an ETL operation, this is what we're selecting from those tables. And then the last thing that we'll do is once we've completed whatever that operation is, a batch operation, streaming operation, we're going to update that change tracking version table, the one that we created to temporarily store that version number. We're going to update that with the ending version, which will become the starting version for next time. So I'm going to go ahead and run this whole thing. Let's see, let me run my changes one more time. All right, so now we should be getting some changes. So here are the changes that we were looking at earlier. So the same 39,000 rows of data. The change that we made here was we're now updating that custom table that we created called change tracking ETL version. The starting or the stopping point for this load, the ending point for this load becomes the beginning point for the next load. So we see our result set here. This is what we selected using change table. Give me all the changes between this version and this version. Now, if I run that same query again, I'm going to get 0 rows, just like we saw a second ago, because we just updated that ending point value, which is the beginning point for the next load, but we haven't made any changes to that data just yet. If I were to go back and run this and update these employees, now I should have a small set of data. Well, it's the 39,000. So I've got some rows of data that we have updated. But again, running that again, nothing has changed since I just ran that script. So now we're getting nothing. So this is working exactly as designed, where when you run your data movement operation, it'll grab the data that's changed, the data that's deleted, the data that's new, and load that one time. Upon that successful movement operation, I update that value, and then that data won't be touched again unless it's later on updated separately, in which case it'll be picked up and loaded the next time. You're not limited to just those insert, update, delete operations. You can integrate this into anything that you can use T-SQL on. So I've got an operation. I'll not run this because it does effectively the same thing. But I wrote a merge statement that uses those same change table functions. So I'm merging into my DW dim employee table, grabbing from change table, left joining employees. And in this case, I don't care about deletes. So you can see that I'm filtering out using sys change operation. I'm only looking for I or U. I'm only looking for inserts or updates. So in this case, we're disregarding deletes entirely. So if the data is found, then we'll do an update. If the data is not found, we'll do an insert. So it doesn't have to be limited to just inserts, updates, and deletes directly. You can use any of the same functionality that you could in T-SQL. You can also integrate those change tracking functions into that as well. And then in the, so Steve, I'll give you guys a zip file with everything that we've got here. I've rolled all the things that we talked about into one consolidated script. If you just want to run the thing end to end. So this will populate the table. It'll make some changes. It'll show the before and after on each one of those. So if you want to have just one script to play with, this is a great demonstration, just an all-in-one demonstration of using change tracking directly in T-SQL. Now, if you're a fan of other ETL tools, I'm a big integration services guy. I do some work in ADF as well. I've used some other third-party tools as well. You can use change tracking in those tools as well. It's just a T-SQL function. So anything that you can use to run T-SQL, you can use change tracking. And this is actually, if I'm running change tracking, this is more commonly the way that I do it. Again, I do a lot of ETL data movement, batch data operations. So I'll either use SSIS like we're seeing here or Azure Data Factory to do something similar where I'm batching up those changes. This is a little more visual representation of what we were doing there. In this case, I'm using a container to go in and grab the current change tracking version. So this is where it sits right now. Write that into an SSIS variable. Do the same thing, but I'm grabbing from the change tracking ETL table that we created to store that value. That becomes the beginning point for this load. Those are my bookends, the beginning and ending. And then I go through the same process that we went through in code, only I'm doing it through integration services. So truncate my staging table. I'll use my data flow task to run my OLTP load. And again, we're using the same type of query that you saw earlier. Use change table changes for employees. Question mark is the placeholder for what that version number, the starting version number is. And then I'm going to grab that where the change version is less than whatever the ending version of that is. So if I were to, if you'll bear with me just a second, I'll reset and then I'll run that package real quick. Make our OLTP changes. So now if I run this, so I see the 39,000 rows that have changed since the last time we ran the ETL. But in this package, I'm doing the same thing that we did in the script where I updated that table. In this case, I'm just using a merge statement. I update that table to insert into that table this current change tracking version. So if I run that again, I should see 0 rows of data. So this is a reproducible process where the second time it runs, because it detects that we don't have any changes in there, it's not going to pick up any data until something effectively changes after that point. So again, with change tracking, there's a couple of functions that you'll need. The change tracking current version is the one that you can run ad hoc to see what's the version number right now for the entire database. And then that changes function, that set-based function that will return all the data for a given period, will return the primary key data, it'll return the operation that you engaged in, the version number, and if you enable the column level mask, it'll also give you that columnar data so you can inquire on column by column, did that column change? All right, let me pause there. Threw a lot at you for change tracking. Any questions about anything that we saw here for change tracking?
Yes, so Julia was asking how change tracking impacts performance.
It's a good question. So I've never run into a case where change tracking has even been a culprit in performance issues. That said, if you've got a really busy table, keep in mind that every change, every batch operation is going to store a copy of that primary key, the change, the version number, which is a big int value. And then if you enable the column mask, it'll store that column mask as well. So there is some amount of IO that's going to take place to store that, but it's not akin to what we'll look at on temporal tables. It's not storing the whole row. It's only storing the change that was made, the primary key column or columns, and then just the metadata that it needs for that. So could there be a performance issue? Absolutely. So if you've got a bunch of tables enabled for change tracking, they're very busy tables. I can envision an edge case where change tracking could become problematic. In all the cases that I've used it in, I've never run into a case where change tracking, we had to not use change tracking for performance reasons.
Then there is a question that you already answered. If you'll be able to share the demo code.
Yes, absolutely.
And I'm assuming you can do it through your blog or through your own GitHub, right?
Sure. Yeah, I've got a GitHub. I can share it out there, or I've got a section of my blog as well that I can share that.
Perfect.
Yep. All right. Any other questions about change tracking?
Any database changes that might affect change tracking? Let's say, I don't know, isolation levels, or I don't know, just trying to throw in some stuff that are not ordinary. Like, I don't know, if you have compression on tables.
Yeah,
would
you
that have
shouldn't have
problems?
any. Yeah, that shouldn't impact. So the isolation level, nothing like that should. The only thing that could impact it is if you change the structure of the table, and specifically if you change the primary key arrangement. So if you have a single column primary key, you decide that doesn't give me uniqueness, I'm going to go to 2 columns. That will almost certainly break that chain, because you're going from, it was storing the change history with the single column, now you're going to 2 columns. But the other change, or the other functionality in SQL Server, I've never run into anything that would either prevent or somehow block the use of change tracking.
Can you truncate a table while change tracking is turned on?
You can, yep. So I don't think that question has ever come up, but yes. Let's truncate table dbo.employees.
This question was waiting for Jonathan.
So now we'll see if we look for select star from change table changes dbo.employees. Let's see. Select change tracking current version 1261. So let's say since 1259. Now that's interesting. You may be on to, so I didn't see who asked that question, but you may be on to something here. Let me test out something real quick. Okay, so 1264 is our current version, 1264. And we do have data in employees. So 1264, let's truncate. And now let's see change table for 1264. So the short answer to your question is yes, you can truncate it. The bad news is, because a truncate it's technically not a delete operation, it's technically a metadata operation. That's not tracked in the same way that a regular delete would be. So that one actually wouldn't show up as a change operation. So if there is a table that you're tracking for that reason, if you're tracking a table that might be truncated, change tracking definitely wouldn't be a good option. Even though you can truncate it, if you go looking for that data, it's going to be misleading, because that operation is not tracked in the same way that a CRUD operation is.
I had a feeling that would be the case.
That's a fantastic question. I've given this presentation probably 8 or 10 times. I don't think anybody has ever asked about truncating a table. So I'm glad you asked about that.
Oh, cool. Now, what if you add a new column or drop a column from a table? while
Yes.
change tracking is on? What happens?
Yes, so that part's okay as long as the column that you're adding is not, as long as the column doesn't change the makeup of the primary key. So if you add a column, that's okay. If you take away a column, that's okay. But if you either add a column to the primary key, remove a column from the primary key, that's going to break it, because effectively under the hood, it's looking at that combination of primary key values to detect what has changed since the last time we ran the ETL operation.
So does it change the tracking version if you add or drop a column or alter a column?
It should not. But since you asked, change tracking. So we're still on 1264, alter table, dbo.employees, add my favorite color, bar chart 50. And now change tracking current version. We still should see 1264. Yep. So just like truncate table, it's a metadata operation. It's not going to log that change necessarily.
Another question related to truncations. So are your previous inserts, are they all still there? So after you truncated, it didn't log that, but you can still see the inserts that occurred prior to.
Yeah, that's a great question. So let's do 1240, select start from change table. So that actually truncates the history as well. So if you're truncating that, effectively there's not, because you've engaged in a metadata operation, it's treating that not as a CRUD operation, but as metadata. So it's getting rid of the entire history. I go back to 1240, I'll go back to 1200, in fact.
I was just
And we're not
thinking
gonna
if
see
I
that.
have a partition table and if I'm truncating a partition, but I have the history from prior inserts where I can track, because I have a situation where I'm reloading the same table. I'm just kind of like truncating and reloading for a specific date. And I'd want to see the delta. That would have been cool, but it doesn't look like it.
Now, since you mentioned that, that's a scenario that I haven't tested out with temporal tables, is if you're using it with partitions, and specifically if you're truncating a partition. Now you've given me something to chew on. Now I'm going to have to go try that tomorrow. Yeah, I haven't tried it out in that particular scenario where if you're dealing with partitions and you're truncating or switching partitions, what does that look like from a change tracking perspective? So Steve, I think your question earlier about would things like compression impact that? It's certainly compression or other facilities wouldn't impact that, but I could envision a case where partitions, and specifically manipulating partitions, either truncating or swapping one in and out, might impact that, because it's a metadata operation and not really a CRUD operation. But obviously the truncation, being a metadata operation, wipes out not just the table, but the history. So I'm going to have to play around with that. I haven't used it in that scenario where partitions were being moved around like that.
Another quick question. Oh, sorry, Steve.
Go ahead.
I noticed you did a merge, and I didn't notice, is it treating insert, update, and delete? Is it adding one for each, or is it counting the entire merge as one?
That's an excellent question. So change tracking current version 1267. Employees using just do 1 = 1. I'm not sure it'll let you do that. think I've got at least one non-nullable column in here, so that may not work. All right, change tracking current version. So yeah, it treated both of those. You know what? There might not have been two different. It might have been
This
that
would
everything
cause just
fell into
one,
the
yeah.
match. Yeah, I think we just
one
had.
operation.
Yep. So on that first name, like, how about that? 1268. Yeah. Got that version number 1268 still. Goodness. I thought this would be a quick one. This is one I may have to get you an answer for later. We'll try this and then.
I was going to say, I'm impressed that you're actually trying to do this on the fly.
Yeah.
Well, they say you're not supposed to type in demos, but since that was a really good question, I want to see if I can get an answer here. Yeah, so it's just one operation. So we started with
good.
12. Yeah, we started with 1268. It's treating the merge as just a single operation. Yeah, even though we've got both inserts and updates.
That's good, because yeah, you want to
Yep.
make sure that if you're looking for the latest one, that you're capturing
Right.
everything that occurred. Okay, cool.
Yep,
Thank you.
absolutely. That's what I would hope to have seen, was that it treats the merge, even though there's an insert, update, and presumably a delete as well, that it encompasses all that. And basically, I don't know if it's the same transaction, but one would think it, because it's the same transaction, it's going to be the same version number as well. I'm good.
What would happen with set identity insert on?
Say it again.
So the question was about truncate, and it's really a gray area. What about if you do set identity insert on the source table?
You set identity insert on, and the primary key is the presumably the primary key is the identity.
Yeah.
It's still just a CRUD operation, so I wouldn't think there'd be an issue with that. So that I think I've done before on a change tracking table. In fact, I was just doing identity inserts earlier today, and I'm trying to remember, it was on a system that had change tracking turned on, but it might not have been a table that was actually tracked by change tracking. Yeah, I don't really think that's going to cause an issue, Steve, but it's not something that I've run into enough to really remember right offhand.
Got it. Thank you.
All right. For the question about partition switching, I am making a note on that because I need to go play with that and see how that's going to impact that. Thank you, by the way, for all the fantastic questions. Every time I do this, I try to add on a little something else, and this is probably the most questions I've gotten out of it. So fantastic. All right, last call for any other questions on change tracking before we talk temporal tables. All right, we'll jump right into it. Temporal tables are system version tables. They work similarly to what you're going to see in change tracking. But unlike change tracking, this will actually store the entire change history for whatever period you specify. So there is a separate table that's created. It's a physically instantiated table that will store the entire change history for that table. It does have the full history of changes. Starting in, I believe it was 2017, there's the option to specify a retention window. So before I believe it was 2017, before that point, it would store those indefinitely unless you turned off temporal tables and went back and truncated at least part or either all of that history or deleted out part of it. But now you can specify the retention window that you want to keep if you want to go down that route. Unless you specify that window, it does keep things indefinitely. And one quick note, unlike using the version number that you see in change tracking, temporal tables actually uses the date timestamp of those changes. Temporal tables are going to be present on any system that's 2016 or newer, and it doesn't require any specific edition of SQL Server. So if you're using even standard edition, you'll have temporal tables there. Some people call this a time machine, which will let you rewind to a specific point in time and see what the data look like as of a given date and time. You can see what the data looks like right now, which is the default, or go back and say what was the data as of a given point in time, what were the changes that took place during a given point in time between X and Y, and so on. I've had a few questions that have come up over the years about, is this an auditing mechanism? You can use this for some lightweight auditing. It's not going to stand up to any scrutiny if it's like an official government audit, for example, because one can go in and turn off the temporal table functionality, theoretically manipulate the data in that history table, and then turn it back on. So you definitely don't want to use it for auditing for compliance purposes. But if you want to see just anecdotally the history of the data over time, it is a pretty good tool to use for that if you don't need actually compliance level auditing. Couple of requirements that you have to have. It does require a primary key, just like most of the change tracking pieces that we'll talk about. It does require that you create 2 new columns that will identify the valid period from and to on every row. But other than that, the table is going to be used just like any other table would be. Your CRUD operations look exactly the same. You can delete from the table, insert it into the table, and so on. And unless a user actually knows the functionality is there, they're not going to see anything different from that table other than it's just a table with my customers or my transactions or my whatever else. One thing to keep in mind here, if you're a code person, this is not going to matter so much to you. There is no GUI support for doing anything temporal related. It's going to show up in the GUI just like you see here. Our customers table is showing up. It's branded as being system versioned, but you can see that once we get into it, if we right click on that table, it doesn't give us the same design options that we would normally have for a regular table. But again, if most of us probably deal in automation anyway, so most of us, I'm guessing, are going to prefer the T-SQL, the automation style, as opposed to the UI style. As I mentioned earlier, it does physically create a table that you can directly query, just like it were a regular table. You can use an existing table if you want. I don't recommend that. I've had a few cases where I've broken and then turned back on temporal tables, but using or inheriting the system, the history from an existing table is more often problematic than actually solving any problems. So you're better off, if you're setting up a table for temporal history, just to go ahead and create a net new table and just start from that point. And you can directly query that history table, but you can't do any modification. You can't do any data modifications to it. Just like change tracking, we've got a few functions that you'll need to remember for temporal tables. They're all based on for system time. So for system time as of a given point. So that top one is the one that you're going to use most often, as of a certain date. And this, keep in mind, that is UTC. So that's not your local time zone. So you'll have to, if you're looking at the clock right now and what did it look like 15 minutes ago, you have to convert that over to UTC. For system time, there's two different sets of inclusive functions, between and from. These are very close to identical. The only difference is if you're using between X and Y, the between includes that upper boundary, that X boundary. So it includes, if you say as of midnight, if something occurred exactly at midnight, it's going to include that. If it occurred 1 millisecond before, it won't. Time from and time to means that whatever changes we're talking about, that row is valid wholly between the X and the Y that you specify. Contained in, I don't think I've ever used that, but for system time in specific time or specific date time to values. And then lastly, for system time all, we'll show you the entire change history for that table. All right. If any questions have come up, I know that was a fairly short slide deck, but if you have any questions before we jump into the demos on this one, let me know.
I'm still confused about the between and the from to options.
Yeah, so
just show like an example.
Do I have an example of that? So we can try to make one up. The challenge with that is because it's using a specific time, we'd have to get exactly on the millisecond that we're talking about for the date time to value. To be honest, I've never used from and to, or actually, no, I take that back. I've never used the between because I'm never trying to get as of between some time frame, but be sure to include whatever the X is. I'll see if we can manipulate that and maybe force it into showing the difference between the between and the container. I'm sorry.
So when you say
between the from and to,
wait, where is it? Where's the from? Yeah, the from and to. You say wholly within X and Y. That means that the X includes the X time is also applies to that as well, or not?
No, so those are the bookends. So it would occur within those, but not inclusive of X and Y.
Oh, okay. I get it. I understand.
Yeah.
Thank you.
Yeah, Microsoft documentation was a little bit muddy on that. Like I said, when I first started going down this path, I didn't even know what between. I figured that one of them was probably inclusive of the X and the Y. The other was exclusive. But as it turns out, according to the documentation, from means that it's everything between X and Y, but not including X and Y. Between is everything between X and Y, but also including X. Is that useful? I've never found a single case for it, but it's out there.
Okay.
All right.
So there is a question if you have a link to the documentation that you are using.
Yes. Yeah, I'll send that to you afterward. It's probably still in my browser history from a few hours ago.
Okay, thank you.
All right, got a script that'll create that data or drop the database and recreate it just so we're starting fresh. So this one just creates, it'll drop the tables that we were previously using if they're already out there. There's nothing to drop since we just dropped and created the database. So I'll zip through those fairly quickly. This is where we actually set up the system version table. So we just created the table called customers. This is what customers looks like. So 663 rows in the customers table. The changes that we need to make, we actually need to run two different metadata operations on that table. The first one is we need to add two columns. One is going to be the starting point for that row to be valid. The other is going to be the ending point for that row being valid. And there's a very specific and weird syntax for this. I don't know that any other column setup uses or any other metadata operation uses this syntax. So valid from date time to, that's pretty generic. Generated always as row start and then generated always as row end. So those are specific to setting this up as a temporal table. So under the hood, what that's doing is every time we insert, update, or delete something, those are the two columns that it's using to track the beginning valid point and the ending valid point respectively for those. The hidden keyword is actually, I believe that's still optional. Hidden will actually hide that column from any operation that is simply listing the columns on a table. So if you use that hidden, it's going to hide valid from and valid to. In every case that I've ever implemented temporal tables, I've always used that hidden option. But you do still have the option if you specify, I want to get select star and valid from and valid to. It'll still return those columns, and you can still query on them, filter by them, group by them, and so on. But if you do as hidden, they're not going to show up in a select star. And then period for system time simply indicates for this table, it's not really adding a column here. It's just saying for the system time, this is my from and this is my to. And then separately to actually enable temporal table functionality on this table, I say alter table, customer set system versioning on, specify the name of the history table. This is optional, so you don't have to say, you can comment this out, and it'll create a history table for you. It's going to give you a name that might be table name history or might be some random name if you already have something close to that name. So I always prefer, if I'm creating a temporal table, I'm going to go ahead and create it with my own naming scheme, and I just use the name of the table followed by the word history. You can let it create one on your own if you want, but this is the way that I typically prefer to do it. So if I browse out, let me change databases, go to my temporal sales, refresh my list of tables. So I just have my one customers table out there. I can go into design, make whatever changes I want to here. But once I run this, now if I go back out and refresh this again, this is going to look a little bit different. So now it shows what I showed you in that screenshot just a little bit earlier. So it's showing that this is a system version table. I can still drill in and see most of what I saw earlier. I can see my columns, all my keys, my indexes, and so on. But if I right click on that, I don't have the option to design it. So I can't go in and add a column in between column 1 and column 2. Once I set this up as a temporal table, my only options for doing anything metadata related are purely going to be in T-SQL code. All right, so once we've got that, and one quick thing I'll show you, if you're using 2017 or newer, you also have the option to specify the retention period. This is an optional setting. If you don't specify anything, it sets an indefinite retention period. If you set 365 days or whatever days, after that period, it's going to purge out the history and take away the history. I don't remember if that's a batch job. I think every setup that I've done, we haven't set a retention period. We've just let it keep it indefinitely. But it will purge that history after whatever retention period you specify. All right, that's just a regular table. So if I do a select star from customers, it looks to me just like a regular old table. If I scroll all the way to the right, those two new columns that I had marked as hidden are not there. I can query and say valid from, valid to, and if I specifically enumerate those columns, it will include them. But just doing a plain old select star will not include those hidden columns. Now this is where it gets a little bit useful. So I can say select star from customers for system time as of a given date and time. Now this doesn't change anything because I'm going to grab the UTC date as of right now and then show what the data looks like right now. Well, it looks exactly like it did 30 seconds ago. So if we start to do something that's other than the current time, in fact, we'll set this, today's the 17th. So we'll go ahead and run this and say select star from customers where system time is as of yesterday, and that's setting value for yesterday close to midnight. I'm going to get nothing. So because we had just created that table, there's no history that goes back to that point in time. I can go forward of that. I can say, go to the 21st, which is obviously a future date. But as far as we know right now, that data on the 21st, all the evidence in hand says that this data looks on the 21st like it does as of right now. Now, if that were to change, obviously we'd see something different. But that's what it's picturing as of this point. I talked about the hidden columns, the valid from and valid to. Those are hidden by default. Now, if we start making modifications, and I've got four different statements that we're running here. So I'm doing an update, another update, another update, and then a delete. I put a delay in between there just so we can see those spaced out just a little bit in our historical table. Now, while that's running, that'll take about 15 seconds to run. While that's running, one thing that I didn't show you earlier was if you drill into your system version table over here on Management Studio, now you've got this table that shows separately, it shows your history table. This is a separate table. It's a physically instantiated table that you can query directly. You can query using some of the functions here. You can make some modifications to this table. So you can do things like add an index. Actually, adding an index might be one of the only things you can do. You can't add a unique index on there, so it actually prohibits that. You can't manipulate data, and you can't add or remove columns from that table. All right, so I had 1, 2, 3, 10, 13 rows altogether that we had updated. So now let's jump over and show those modifications. So what do those customers look like right now? So for these 1, 2, 3, 4, 5, 6, 7 customers that we have, this is what they look like right now. So we're not using the for system time functionality. So it's simply showing those customers in their current state. Here's where we start to use some of those functions. So for system time all, this is going to show not just what those look like right now, but the entire change history for those rows. So select star and then valid from and valid to for system time all, and the customer ID is just these 7 specific customers. So now we're getting more data back. So these are sorted by customer key and then valid from. So you can see this one customer has had 3 different updates applied to it. This one has 2, this one has 2, and so on. So it's storing not just the primary key like we saw in change tracking. This is actually storing the full change history. It's not necessarily going to tell you what column or columns have changed. It just recognized that there was an insert, an update, or delete operation on that table, on that row of data. So it stored that in history based on that insert, update, and delete. And then let's say if we're going to go back to just a few minutes ago, we're subtracting 15 minutes from the get UTC date. So what did those customers look like 15 minutes ago? They look like nothing because we just inserted that data a little bit ago. If we go back, however, 2 minutes, that's what those customers look like at that point in time. So we can rewind to any point for which we have history. Again, the starting point being if you insert the data today, right now when we insert the data is the furthest back that we can go on history. And then show our deleted customers as of now. So 23, 24, 25, there's nothing to show because they've been deleted. But again, if I go back into for system time all and show all those customers, I see that 23 was simply deleted at some point. 24 and 25, there was more than one operation there. So there was some update that took place before those 2 records were deleted for both 24 and 25. And then our for system time for the gentleman's question a little bit earlier. This is using for system time between 2019 and October of 2018. So there was for all 5 of these rows, for these customers, there was some intersection where they were valid within that period. So one of those, either the valid from or the valid to, was within those parameters that we specified, was within those 2 dates that we specified, which is everything at this point. We don't actually have enough history to really see any further back than that. But you can see how you could use that if you were looking for the between, as long as that starting point that we're not hung up on if it's inclusive or exclusive of that, either using between and or using from and to should yield pretty much the same result. The only differentiator is if one of those fell exactly on that X component, on that first date component, would it be included or would it not? It would be included with between. It would not be included with from and to. All right, and then for the underlying tables, there are 2 different tables that we have here. The one for customers is pretty self-explanatory. That's simply the table that we initially created and then later added on the temporal functionality to it. And I'm just grabbing one customer ID here. If I go down and query that customer's history table, as I mentioned earlier, I can use the temporal functionality and say where the time was a certain time, or I can say, just give me everything for that entire history. What did this customer look like? One thing to keep in mind is if you're using this history table directly, as we are here, this is only showing the expired historical data. This is not showing the current data. So if I wanted to get something akin to for system time all, I have to do something like this, or union those 2 result steps together, because effectively that's what we're getting when I show for system time all. It's getting the amalgamation of what's currently in customers and what's historical of the customer's records.
Hey Tim, can you show the execution plan on that for the system time all?
Yep, absolutely.
Okay, so it actually is unioning them together. Okay.
Yep.
Thanks.
Yeah, so physically, that's a great question, Rob. Physically, it's actually doing that very thing. So if I were to grab customers and customer history and union those together under the hood, this is sort of doing the same thing. It's grabbing everything that's current and everything that was historical based on whatever we filtered on and bringing all those together. Actually, thank you, Rob, for that. I'm going to make a note. Next time I do this, I'm going to bring up the execution plan. Right. And then let's show a little bit of manipulation on there. So if we were to manipulate the metadata on that table, so let's add for customers, let's add favorite color. That wasn't previously on there. Default value is blue. And this is interesting. I'm setting this to not null and default value is blue. If I go look at that data now, so all the current data, as one might expect, setting a non-nullable with the default is going to set that to blue. It does the same thing on the history table, interestingly enough. So it's possible to implicitly manipulate that history by adding a not null default column there. And then we can remove that column. Let's take off the default, and then I'm only going to drop that. You see, I'm altering just the customers table, and I'm dropping the column called favorite color. And now if I query both those tables again, even though I just dropped it from customers and not customers history, it's removed it from both tables. So really the columnar metadata is intended, it's designed to match between the parent table and the history table. Now I'm going to go directly into customers history, and I'm going to add shoe size, but it won't let me do that. So it's not a supported operation. This is by design, that If you've got a history table, it needs to match schema-wise, it needs to match what the parent table looks like. So it's going to prevent an operation like that. However, if I go in and say I want to add an index to that customer's history table. So again, this is bypassing the parent table entirely. Just add an index to that history table. It'll let me do that. What about a unique index though? So fortunately, it prevents you from doing that. And it's probably a good thing that it does, because that's a recipe for disaster. At some point, if you got a history table, if you have any combination of columns, you're going to have duplicates in there at some point. So it actually prevents you from adding a unique index by design.
If you add an index to the base table, you're just about to answer my question.
You're a step ahead of me. Yep. So if I create an index on the base table, what's the impact there? So it lets me create the index on the base table. But if I look at, do I have an index called customers_custname? Let's refresh here. So here's my index. There's customers_custname. But if I look at my history table, it does not have that index. So even if you go in and add a column, it's going to propagate that change down to the history table. If you make an index change, it doesn't make that same propagation, because the index actually doesn't impact the table schema. So if you're creating indexes, you do those separately on the parent table and then on the history table if you want to create indexes. All right, and then finally, if you decide that you're done with temporal tables, you can alter that table and set system versioning equal off, and then drop period for system time. You actually have to do both of those to fully rid it of the temporal functionality. And once you do that, if we go back in and refresh the tables now, so now customers looks like just a regular old table, but what do you know? We've still got the customer's history table. So if you demote this table from temporal to just a conventional table, it doesn't get rid of that history table. So the history table is still there, and it's still going to have all that history as well. So all those changes that were made up to this point are going to still be there. Now, if we wanted to, if I go all the way back to set up system versioned, so if I'll need to make one quick modification to this. Let me just create a new window and do this. This is why they say not to type in demos, but I think this will be useful to see. We've already got those columns valid from and valid to. We just want to add period for system time and then turn back on system versioning. So because I turned on system versioning and told it use the history table called customer history, it didn't purge and then create a new table, and it doesn't start the history over again. So now if I go in and say show post modifications, so show me those customers. Here are the 7 customers that we were looking at. But if I look at the deleted customers, the history for the deleted customers, if you'll remember, 23, 24, 25 were all deleted. But if I look at for system time, look at why would that be ambiguous now? That's interesting. Since those are still hidden columns. So you can see if I do for system time all, when I specified that new or that existing table, it didn't start over with history. It inherited all of that history. So that's the reason that I said a little bit earlier that if you're looking for an auditing mechanism that really is regulation ready, this is not it. Because if someone has the appropriate permissions, they break the temporal table functionality to turn that off for that table, they could manipulate that historical table and then turn it back on and show a different history than what actually occurred. So if you're looking for something lightweight for auditing, just for, again, for anecdotal evidence, then absolutely it's a great way to go. If you're looking for something it's going to be recognized by a regulator for proper auditing, this is definitely not the tool for you.
Can you scroll all the way to the right, please? I mean,
Sure.
the results.
Yeah, now that's curious to me because we had created those columns as hidden.
Right.
What I'm thinking is when we did add period for system time, perhaps that made those columns implicitly made those columns visible because previously they were hidden columns. So I'm not quite sure why it treated those that way.
Well, isn't there an option here where you can make them hidden? Isn't there a hidden option?
So there is, but it's actually when you add the columns in there. So when we added the column, this is actually where we added the column on that first step. We're adding the new column called valid from, date time to, yada, yada, yada. This is the keyword that makes that hidden. Since we had already used those or we had already created those columns, you know what? I think I may have just answered my own question. Let me see if I can do this. Alter table, customers, alter column, valid from. Can I just do this again? I don't think this is going to work. Can I just do the hidden keyword and not change the nullability?
Interesting.
Yeah, so I'm not quite sure what the mechanism is that changed that from it was hidden and now it's not anymore. But that's why I was getting the error whenever I was querying earlier about ambiguous column name because it had 2 valid froms and 2 valid tos. Right, so we went through the metadata operation, so we know what we can and can't do with that table. We can add columns to the parent table. We can add indexes to either one, but we can't add a unique index to that child table or to the history table. So temporal tables, I don't use temporal tables nearly as much as I use change tracking. Just again, that's mostly just a function of the type of work that I do. They're both really valuable to have. If you need the full change history, as I mentioned, change tracking is not the way to go, but temporal tables will definitely help you out with that. If you're looking just to identify the rows that are new, that are changed, that were deleted, using temporal tables is probably overkill. You might look at using change tracking instead for that. Both are fine tools. There is quite a bit of overlap, but hopefully you've got at least enough information to help you decide which of the two would be appropriate depending on what your change detection needs are. All right, so with that, let me open up for any other questions.
Would temporal tables use less overhead than change data capture?
So would temporal tables use less overhead than change data capture? I would think over the long haul, from a storage perspective, temporal tables are going to use more space because you've got a shorter retention window by default if you're using change data capture. And that's typically, it's just using information that you have in the logs whenever you're doing that. If you're using temporal tables, just by design, you're probably storing that for more than a few hours or days at a time. So it's going to build up more in terms of storage. Performance-wise, I don't know that you're going to see that much difference, but over the long haul, you're going to see more storage needs probably with your temporal tables.
Okay.
right. Any other questions on either temporal or change tracking?
Hey, Tim, I had a question. I kind of forgot the wording of it on the change tracking, where you had you're storing like the latest change version for a table. Do you ever have a need to maintain like a history of those versions in case you had a say a 14-day outage? How would you accumulate all of the changes that happened over 14 days, all of the versions that happened over 14 days to get them pushed over?
Yeah, that's a good question. So in an event like that, so the short answer to your question is no. I don't store the history of each one of those versions. What I do is if I run a data load process, at the end of that load process, I'll update that value with whatever the value for that ending point was, which becomes the value, the starting point for the next load. Let's say we have a 14-day outage and the process, for whatever reason, it can't run at all. That means that nothing would have run in those 14 days and that value for change tracking wouldn't be updated, right? So in that event, rather than having, so let's say if I'm running a 24-hour cycle and I run my load at 6 a.m. every day, if I had 1,000 changes on any given day, and then I have, we'll say a 3-day outage, the first time I run that load process, it's not going to look for the 1,000 changes that happened in the last 24 hours. It's going to go back to the last time for that stored value, the last time that we successfully ran the ETL was 3 days ago and 3,000 versions ago. So we're going to go back to that point. So the first time you run the ETL, if you're doing a catch up like that, it's going to be a longer period of time. But it's not using individual versions. It's actually collecting all the changes that have occurred since version 3001 to version 6001 and encompassing all those in one big load.
Okay. Yeah, it makes sense. You're keeping the last load version on the destination side. So
right,
okay.
The last successful load version, correct.
Right. Okay, thanks.
Yep.
You saying successful load version, I'm assuming that implies that your ETL needs to handle a potential failure, and then you only write the versioning upon success.
Correct.
So something to think about.
Right. And I've had cases where we'll handle either very granularly or very broadly. So in most cases, if I'm doing that, I'm doing the loads on a table by table basis, or I'm doing the versioning on a table by table basis. So if a given table is successful, the next time the ETL runs, it'll grab the changes for that one table. So if another table load that's unrelated to this one were to have been loaded and failed or didn't run at all for some reason, then independently, that's got its own starting point for its next load. But if I've got a lot of interdependencies where I want the entire thing to either succeed or fail, then rather than doing that on a table by table basis, I'll do it on a process by process basis, where I'm not considering that to be successful unless all these moving parts were successful. And only at that point do we update that and say this was a successful load. So next time we run that, this ending point where we were successful becomes the beginning point for the entire load, as opposed to going table by table for those decisions. All right, any other questions? Temporal tables, change tracking, how well I expect the Texas Rangers to do now that they've changed management.
If you were to compare both temporal tables and change tracking, which one is heavier?
Which one has the biggest performance impact?
Let's call it overhead.
Overhead, almost certainly temporal tables, because you've got more long-term storage, because it's storing it's storing more data, and B, it's storing it just by design. It's storing it for a longer period of time. But with the I/O as well, because when you're writing to disk, whether it's an actual disk or electronic storage, you've got the overhead of writing that much more data to process the entire row, as opposed to for temporal tables, as opposed to if you're doing change tracking, it's just writing the primary key, the type of operation, the version number, and if you use that column mask, it includes the column mask as well. So
Got it.
there might be an edge case where you see change tracking has a performance impact that outweighs what you would have on temporal tables, but I would say that's a very, very small chance of that. Just because temporal tables by design, it's going to move more data, touch more data. It's going to persist that data for a longer period of time.
Got it.
Is there anything in change tracking that would allow me to track schema changes?
Is there anything in change tracking that would let you track schema changes? Unfortunately, no. It purely is data changes.
Data changes.
Yeah.
Thanks.
In terms of backups, basically any difference that is there anything that you need to introduce if you're using change tracking or temporal tables? You're basically introducing either one or the other. Do you need to do any changes to your backup processes?
You don't need to change your backup processes at all. Again, the only provision there is that if you're heavily using change tracking, or if you've got a significant amount of change that you're tracking with temporal tables, it can impact the size of your backup, because for whatever period of time that you're retaining that data, it's not just in the database, but it'll be in the backup as well. But as far as the mechanics of doing backups and even restores, you're really not going to have any difference in the way that you're doing that for either change tracking or temporal tables than if you were just doing a regular database that didn't have either of those things in use.
So you prior to that did a backup of, let's say, customer stable, employee stable.
Mm-hmm.
You introduce change tracking to that employee stable. You're still doing a backup. You're still doing restore, and it's going to restore with change tracking.
Correct. So for wherever you were when that backup started, just like the database works, it's going to store transactionally wherever that was at that point in time. It'll restore to that point in time, including whatever changes in change tracking that were made up to that point.
And this is also applicable to temporal tables.
Correct. Yes.
Even though temporal table, the history table is a separate table.
Right.
Okay.
Yeah. Under the hood, it's on temporal tables. It just makes that table more visible because it's a physically instantiated table. But yeah, as far as the backups go, it's still just doing a regular old on the wire backup, or on the disk backup, just like any other backup would do. Got it.
What about in terms of indexing? Can you do different indexes to temporal tables?
So because it is possible to do different indexes on the main table versus the history table, it's theoretically possible to get, shall we say, creative with the indexes. I've really not done that. So I'll typically try to align the indexes on the history table more or less with what we have on that main table. I think the only exception might be if you were doing a lot of queries where you're only looking at history. It might be worth exploring adding some indexes just to make those covering indexes for that history table. But I've never been in a situation where I've really needed to do that. If I'm using temporal tables, I'm going to use the temporal table functionality, which means that from an indexing strategy, I want both tables to be more or less in agreement as far as how they're indexed.
Got it. Thank you. So,
all right. So everything,
screen.
Yeah, I was going to say everything that I've shown so far. I'll zip all that code up. So for both temporal tables, change tracking, as well as the SSIS package that I showed, I'll zip those up. And you've got actually, I don't have my website on here. If you go to, let me go back a few screens.
Wait a second, delete. Okay, go ahead.
I was going to say, if you want to go to my website at timmitchell.net, I've got a resources page out there. And if you want to go out there, I'll just dump this code. I'll put everything in a zip file. Let me share just real quick this window so you can see that.
I think the best is if you can paste it into the chat.
Oh, yeah, that's fine. So yeah, I'll share that out on my website if you want to go down and pick that up. It'll be, I'll have it there tomorrow, so you can download that. So, and obviously you'll have my contact information on there. So if I can answer any questions about either of these topics, or if you ever need assistance with data architecture, ETL, data warehousing, I'm glad to chat about those topics as well.
Thank you everyone for joining our online meeting today. With that, thank you and have a great day, and see you and hear you in the next meeting. Thank you.
Thanks, everyone.
Thank you.
Bye-bye.
For the great presentation.
Thank you so much.
Thanks. Bye.
Great job. And
Thank you.
All right.
See you in Seattle in a couple months.
Yep, I'll be there.
All right. See you there.
All right. Bye.
Take care.